Welcome back, everyone. Till now in kinematics, we've seen what is distance and displacement. We've seen what is speed and velocity. And we've also seen the difference between instantaneous and average velocity. Now we move on to the next concept, which is acceleration. So let's take some scenarios given here. Scenario number one, scenario two, and scenario three. Now, the actual definition of acceleration, we are going to look into it later. But let's just observe what is happening in these three scenarios, okay? In the first scenario, you can see there's a person running and snapshots have been taken at t equal to 0, t equal to 1 second, t equal to 2 seconds, and t equal to 3 seconds. And let's see what is happening in this 1 second interval. So from 0 to 1 second, the person covered this much distance. So in 1 second, it's covering this much distance. Whereas from t equal to 2 to 3 seconds, it's covering a larger distance. We all can see that, right? So this person's speed is increasing with time. And when that happens, we say that the object is accelerating. The average speed for the journey from A to B, B to C, and C to D. These are three intervals. All intervals are of 1 second only. Now, within these three intervals, the distance covered is different. So in the first interval, let's give it a number. Let's say 10 meters is covered. 10 meters is between A and B. And then 20 meters is the distance between B and C. And finally, 30 meters is the distance between C and D. And all these distances, all these different amounts of distances are being covered in the same time, 1 second. So this part of the journey also, 30 meter is covered in 1 second. This part of the journey, 10 meters is covered in 1 second. That means the average speed for the first part is smaller than the average speed for the second part. Yeah, that means what? The speed is increasing. The speed is increasing. At least the average speed for different parts of the journey, we can see it increasing. If such a thing is happening, we say that the object is accelerating. Okay, let's look at the second case now. What is happening here? Again, the snapshots are taken or the records are measured at t equal to 1 second, t equal to 2 seconds, t equal to 3, and time t equal to 4 seconds. Now, from t equal to 1 to 2 seconds, the person was covering 30 meters distance, 30 meters distance. And from t equal to 2 to 3 seconds, the person is covering just 20 meters. And from 3 to 4 seconds, it's covering only 10 meters. So here also we see that the speeds for these three different parts of the journey is not the same. The average speed is different. The average speed is decreasing in this case. So even this kind of motion is known to be accelerated motion. It's just that the acceleration value is negative. So we also call it decelerated motion or deaccelerated motion or retarded motion. These are different names for this, okay? But overall, we can say that acceleration is present here also in the first case, acceleration is present in the second case also. Acceleration in the first case is positive, acceleration in the second case is negative because the speed, the average speed for different intervals, it keeps on decreasing. Let's look at the third case now. What do you think? In the third case, in the third scenario, is this B accelerating? Let's look at it. So this is our third case. And it is given that the speed of the bee is not changing. Okay, the speed of the bee is the same. So the bee is going, let's say, at 2 meter per second. That's the speed here. Here also it's going in this direction, but at the same speed. So everywhere the speed is the same. So if It's going in this direction, then going in this direction, 2 meters per second everywhere the same speed. So speed is not changing, right? We can say that the velocity is changing because velocity is nothing but the combination of speed and direction. So if velocity changes, an object has acceleration. Okay, so that's the definition of acceleration. Acceleration is whenever there is a change in velocity. Remember, acceleration is defined in terms of velocity, not in terms of speed. It is a vector quantity and it is defined as the rate of change of velocity. Remember, velocity, not speed. If the velocity changes from u to v for 1D motion, and this change happens in a time interval delta t, then acceleration is going to be defined as the rate of change of velocity. That means change in velocity upon time taken. The change in velocity would be written as final velocity minus initial velocity. So in this case, v minus u upon delta t. Thus, acceleration gets defined as delta v because v minus u is nothing but delta v. It's the change in velocity, delta v by delta t. This is how we define acceleration. So what is acceleration? It is the rate of change of velocity. It is a vector quantity, right? Now, just like we define velocity as the rate of change of displacement, and we saw that there were two kinds of velocities. One was average velocity. Whenever we talked about a journey as a whole, we talked about average velocity. And then there was something called instantaneous velocity. Whenever we try to figure out what is the velocity at a given instant for a very, very small time interval, let's say at 1 second, what is the velocity? Then we are talking about instantaneous velocity. Similarly, acceleration is also classified into two types: average and instantaneous. So we have something called average acceleration. Average acceleration is what we saw just now. Acceleration average is defined as delta v upon delta t. That means velocity final minus velocity initial upon delta t. That means we are talking about a final position of the object and an initial position of the object. We're not bothered about how this motion happened. We're only bothered about what was the final velocity, what was the initial velocity. That's all. So that is how we define average acceleration. Again, I'm reiterating, acceleration is defined in terms of velocity, not in terms of speed. Right. So what if I have to find out acceleration at a given instant or for a very, very small time interval? Let's say from t equal to 1 second to t equal to 1.0001 seconds. If I have to find out the acceleration in such a time interval, such a small time interval, I call that an instantaneous acceleration because it's almost as if saying what is the acceleration at time t equal to 1 second. Okay, if the time interval is so small. And that's where the concept of instantaneous acceleration comes into picture. It is defined as delta v by delta t itself, but where delta t is very, very small. So limit delta t almost going to zero. Okay, so such an average acceleration where delta t or the time interval is very, very small, such an average acceleration would now be called as instantaneous acceleration. As simple as that. Okay, that means instantaneous acceleration, which is defined as limit delta t is being very, very small, almost close to zero, delta v by delta t. This is your definition of instantaneous acceleration. And this quantity can be written as dv by dt. A very, very important result. So instantaneous acceleration is given by dv upon dt. So a big change is represented by delta. This represents a small change. So this big change, small change. Because of a small change in time, dt, there'll be only a small change in velocity. That's why velocity we are also expressing as dv. Okay, so this is instantaneous acceleration.